In this video, I'll be covering slice patterns. Slice patterns allow you to match on specific patterns of data within a slice. Slice patterns have a handful of use cases. One would be to read the first few bytes of a slice to determine header information, for example, for a file. And then you can take different actions based on that header information using a match expression. Another use case would be to get the first or last elements of a slice. And since we're working with match expressions, there's no need to do any bounds checking. The compiler will always ensure that we access data that's within bounds of the slice. Let's start with an example. Here we have a vector of characters, A, B, C, D, and then we match on the slice of the characters. On this first match arm, we're matching on a slice, and we can tell because we're using square braces. This variable named first will take the first element of the slice, and this variable named last will take the last element of the slice. These two dots in between means ignore everything between the first and the last. One thing that's important to note is if the slice only has two elements, then these dots will match 0 elements. So we'll have element 0 and then element 1. So this does not guarantee that there's something in between the first and last elements. On the second match arm, we're only matching one element. So this variable single will match if the slice only contains one element, period. So if it has two elements, then this will never match because this requires the slice to only have a single element. In this last match arm, we're matching on an empty slice. So if the slice is empty, then we'll take whatever actions indicated. On the second example here, with the first match arm, we're matching the first two elements and then ignoring any other elements. Remember, when we have the two dots, it can match 0 or more elements. So this first arm will match 2 or more elements. On the second match arm, we're matching 0 or more elements, and then we want to grab the last element in the slice. Since the two dots can match 0 elements, this match arm will trigger even if there's only one element in that slice. The last arm is again an empty slice, so that'll match if there's no elements within the slice. Since we're using match expressions, if we forget, for example, to have an empty slice match, then we'll get a compiler error indicating that we haven't covered all possible scenarios. One thing to keep in mind when working with slice patterns is that the patterns easily overlap, so you'll want to minimize the number of match arms in order to avoid bugs. Let's take a look at an example. So here we're just matching on some slice, and this first match arm takes the first element, and the second match arm takes the last element. However, since the two dots will match 0 or 1, this first one will match if there's only one element, and then the second one will never be matched. Also, if there's two elements, the first one will still be matched because it'll take the first element and then the second element, and again, we'll never reach the second arm. So this code will be a logic error because this second match arm can never match because this first one will always consume any number of elements, either one or more. One way to prevent these logic bugs is to match the largest patterns first and the smallest patterns last. If we take a look at this left side, we have a logic error. So the first match arm matches an empty slice, which is fine. And then the second match arm will match one element followed by 0 or more. And since this has 0 or more, this second match arm will match any number of elements after an empty slice. This means that the third, fourth, and fifth match arms can never be matched. If we were to flip this match expression around and put the largest ones first, we'll see on this first match arm will match 4 or more elements, and that's okay. The second arm will match 3 or more. The third will match 2 or more, the last will match 1 or more, and then we'll have the empty slice. So on the one on the right, all of these match arms can be triggered under their specific scenarios. We can also utilize match guards and match bindings when we work with the slice pattern. So here we're matching on a slice pattern as indicated by the square braces. So we'll take the first element only if the element is between the range of 1 and 3. We use the @ symbol to bind this value to the first variable, so it would be available within this code here. This rest variable is bound to the rest of the slice. So whatever is remaining in the slice will be placed into the rest variable as a new slice. In our second match arm, we're just taking a one element slice only if the element happens to be a 5 or if the element happens to be a 6. The third match arm just takes two elements, and these last two match arms are required in order to satisfy the exhaustive nature of the match expression. So without these two, we'll get a compiler error because we need to handle all situations. To recap, slices can be matched on specific patterns. These patterns can include match guards and match bindings. You'll want to match on largest patterns first, followed by smaller patterns, and that's because smaller patterns tend to be greedy, and you could end up with bugs. You can also avoid bugs by minimizing the number of match arms in order to prevent overlapping patterns.